You're here to find out about Callaway's brand new Elite Core model, and we have got the best data in the industry for you. Mark Tim's Coolclubs Worldwide Golf. We've got our brand new robot. We're going to put the Callaway to the test, the first one of 2025. Mark, let's
Yeah, this is kind of fun, isn't it? We finally got the robot all set up and working. This is our standard test, right? So it's a relatively, benign swing, not much face rotation. You get dead zero, square at impact, zero path, zero face, club's dead square at impact.
Yeah.
And then we look at, even in the center hits, it might go a little left or right. That kind of shows how much draw bias it is. And we'll kind of explain that on the graph a little bit. But yeah, let's give it a try.
Well, let's talk about the head. So we've got 10.5 degrees. We're going to run this at 95 miles an hour because we think that's basically who Callaway have aimed this at as the biggest portion of this market at least. This technology, so Callaway ELYTE, ELYTE, a nod to Eli Callaway, I'm sure. And this is, it's hard to beat AI smoke. Unbelievable year for Callaway.
Yeah, they really did well all around. I mean, all the robot tests was really good everywhere.
And that's the exciting thing about this year. We get to robot test it and do all these different things, but it's kind of scary for us because everyone done a great job last year. And how does the industry keep pushing technology forward? Hopefully, this robot's going to start evidencing maybe that it's not necessarily going forward, but we're working things out about how to make things a little bit better each time.
Yeah, it's really most of the big advances these days really are in how forgiving it is off center, right? I mean, it kind of maxed out dead center. As long as you get your launch and spin right, they're not going to get a lot more speed out of that. But what happens if you miss it? And everybody does, even tour players. So how good are the misses is kind of really what the thing's about.
Well, let's talk about a little bit about a test, and then we'll jump straight back into the product. So the test, like I said, 10.5 degree, 95, 0, 0, 0. But we've gone dead center. 3/4 of an inch across towards the toe, 3/4 of an inch across the heel. That's a big miss hit. So we're going to see some difference. And now we've got Glenn in the background. Glenn's going to run the test live for us. We've run a big test, 10 shots at each, qualified the data. Mark's run his eyes over it. Tom's had a look at it. We've put it all into a nice package for you to see up on the screen when the time's right. So for this, so you haven't got to watch an hour and a half of testing, Glenn's going to hit a shot from each. We make sure that it sits in the middle or roughly what we did see in the big test, and then we'll be able to talk about it. So let's have a look at the product. I mean, great looking this year.
Yeah, it looks great. I mean, it's all matted out. There's not, not real shiny or anything. It's all black and white. There's no colors on there. I like black and white, as you can tell. So nothing to really bother anybody. And it's got a little green on the bottom and stuff, color-wise. I mean, I like the finish on the carbon. It looks a little different.
And it's carbon. This is a new carbon crown. Material change, which means mass change. So
a little lighter, so they can put more weight other places.
And now we have got more weight other places.
Yes.
This is completely new structure for what Callaway.
Yeah, we've seen a lot of different things. We're using slides, and some other companies have had little screw-in things. But the way they're doing it here is you got 13 grams. They're moving it, from here to here is almost 2 inches. And we've seen from the tests, we've seen so far, even in the center, it's a little bit draw bias, 8 yards or so. But obviously we'll do tests later. We got more time, obviously, after we finish all the new ones, and see how much difference this makes.
Yeah, and what what you're going to get out there in the field when you're actually doing this. See this weight up front, which means they've dragged CG a little bit closer.
And they've got a little bit of adjustability here, so they could, you could move more weight forward. Obviously, the more weight goes forward, you lower launch, you lower spin, get more ball speed, but get less forgiving. So that hurts the MOI.
And this is something you can see, but you can't really see. So the new AI face. We know about AI. They basically plug all this data into a computer from robot swings and golfer swings. So people that swing down and left and hit it in the heel and up and right and toe it, they get the best out of the face. This has got 10 times the amount of information into that face and 10 times the amount of different spots allocated to all these different impact conditions. So we're going to put it a little bit to the test across the face, but we're not going to start doing anything up and down.
Yeah, later we'll get into it. And obviously, when we do our tests for our fitters the data, we actually do 14 points. So it's a lot of points, and it takes a long time to do that. 14 points, 10 shots each, 140 shots. You got everything lined up. You throw some out. It takes some time. But for this test, to get started and stuff, see what center, heel, and toe do. Okay.
The other thing to note is, and we talk about this in our explanation, if you go and watch that video, but basically, as you swing a club, it toes down. So we try and level it out, but we've leveled it out somewhere in the middle range of the lie angles of driver, which go from 54 all the way through to 60, so that we will see flatter lie angle drivers get the benefit of their flatter lie angle and cut more. and more upright drivers draw more.
Yeah, as opposed to other clubs that you're hitting the ground with most of the time. Obviously, the line angle is really important. The club's got to hit the ground smoothly. If the toe digs in, it twists and drives on a tee. So what the designers actually do with this line angle is that's a way to affect, how its draw bias, basically. So you make a more upright driver, and, obviously the face is aiming more to the left. So that makes it go left. And so, that's part of the design parameters of the driver.
So let's talk about a little bit more about the design parameters. 57-degree lie in this driver, 460 cc's. We're going to see that across the board pretty much.
Right.
And then we've also got some other data, which we're really thankful for. Tom Mace runs all this back of house. We've got a total MOI of 9,139, so it's pretty high MOI.
Yeah,
and that's
absolutely.
those two, that's the left, and up,
and Callaway really
combined.
hasn't touted the MOI thing as much as some other ones. And obviously, arguably, is MOI important? Yes and no. It's one of the design parameters. It's not everything. They're more into the AI face and what happens when you hit in different spots. So, essentially it's the same thing.
Yeah. We've also got another measure, and I'll show it from this kind of angle or this angle, doesn't matter. We're looking at the CG depth. So if the shaft axis is in the front here, the CG depth is as the CG is working this way, front to back of the driver. This is 0.948 inches back from the golf shaft. We haven't got any relativity for you right now, but you'll start seeing that in all of our reports. You'll start seeing,
we'll do a specific thing on just the MOI and list them all and kind of show you the differences. It definitely is part of the equation. It's not all of it, but it's definitely something.
Yeah. So now you know the technical information about the driver, what Callaway have tried to do with it. Now Glenn's going to put it to the test for us. We're going to run it, and let's hit the center shot first, mate, and see how we go.
Yep.
So this is definitely my favourite bit of the machine. Is
you like the ball loader.
The ball loader, right? I think everyone's going to love this. It's a golf geek thing.
Yeah. And the shaft's back at an angle actually, so it just clears out of the way of the ball loader. So
just gives
it's not a Mo Norman swing here. You're starting from back there.
Oh, that thing's cool. Okay, now Glenn puts it back in kind of position, and here we go. Centre shot, 95 miles an hour. And you'll see this data come up. So, it's a robot, there's a golf shaft moving. It's not going to be absolutely perfect every time. That's why it takes a lot of shots to qualify it. We'll see what we get. All right. I mean, I know from the ball flight, that's kind of what we were seeing out of the centre test anyway, a little draw.
Yep,
so
which is great. And what we've got kind of two trains of thought here. We could line it all up and get the center shot to go in the center and see where it goes, left and right from there. Or we can line everything up 0, 0, face square, face everything else. And the reason we do it that way is because it kind of shows us the tendency of the driver, right? Yeah. So this is slightly draw biased in the center position. Obviously, you move it to the heel, you probably see it more left. On the toe, it's probably pretty straight, right?
Yeah. It's going to come right off target and come back onto it.
And some of the LS drivers would be the opposite, right? They're almost, can be even fade biased. So it's kind of nice to see that part of it.
So let's talk about, is that good? Was that pretty much in the middle of the...
It's close.
Okay,
yeah, close.
That's what we need, close to the average. So let's talk about the average. Center shot, 138 miles an hour ball speed. Again, we haven't got any reference for you to say, this is what all the 25 drivers are doing, but just know that it's 138. Launched at 10.8 degrees, 2,227 RPMs, average of -6 degrees tilt. That means the ball's tilted to the left, and that's why you see that draw flight. Right. And then it carried 227 yards. We don't really care necessarily?
No, not so much. You're really looking at the ball speed, the launch angle, and spin relative to other clubs, right? So if you're looking at all these test stuff, we've done a bunch of them, and we can compare them and do some stuff on that. Obviously, you're a high spin player, you're going to look at the ones that spin a little lower,
right.
And the opposite. I would never get interested so much in the distance on this. Keep in mind that distance doesn't really mean anything. If you got the right launch and spin, you put a 12-degree driver, it's probably going to go further at 95 miles an hour than a 10.5. If you hit up on it, it's going to go further. If you hit down, it's going to go shorter. So the distance is not such a big thing. What we're really looking at is the ball speed. How does it launch relative to the loft that's on it? Obviously, how much spin do you generate relative to other clubs? And then obviously the tilt axis, the bias is pretty big. I tend to fade a little bit, so I'm not looking at anything that has any kind of right bias.
So this is already in your wheelhouse, right? And the whole intention of what we're doing here is to help you make better informed decisions when you're purchasing golf clubs. So you might be a toe hitter of the golf ball, and now Glenn is going to move the robot. Well, he's actually going to move the tee to the toe section. We're going to move it about 19 millimeters, which is kind of 3/4 of an inch.
Right.
Imperial, go get it. And then we're going to hit the shot again, and we're going to see the data.
Yep.
And we're going to kind of talk about it a little bit differently because we know what this does from the middle and it's good. Then we're going to kind of make it a little relative to like percentage loss and launch changes and those kind of things. So Glenn's just kind of nudging the T across here. And I don't know if you'll get this from the GoPro angle, but that T is going to move just towards the toe. You see the wheels moving next to the GC quad there. And then we'll load it up again. And I mean, again, the little robot loader is cool. It now knows that the T's moved,
right?
And it's going to put the ball in a different position.
Yeah, it's kind of fun actually. You know, where we're in this. Basically, we calibrate it, we move it over and put the ball on a T, and it knows where that is. And then from that, it talks to the machine, so it knows when it moves in which direction and how to move it over. Yeah. So,
seems simple, but it's pretty cool. Okay. So in this test, we're kind of looking for 0, 0, 0 again, but we're going to see the strike point 19 millimeters towards the toe.
Right.
All right, completely different start line.
Yep.
As we'd expect, right?
Yep.
Roll and bulge, we start seeing.
And some gear effect, right?
Gear effect.
Starting a little bit right because the thing's twisting, but it's spinning the back end, yep.
So it launched, started right of target, moved back, and Glenn's going to confirm with us how that looks relative to numbers. We got 22 millimeters off the toe, so maybe a tiny bit further, but that's fine. Backspin, launch.
But it's pretty much right on the target line.
Right, it finished on target line, right?
Yeah, which is pretty much exactly what we saw in the test on the other 10. So
close to the average.
Close to the average?
Really close to the average, yeah.
Okay, so let's talk about it. From the toe, as an average, we lost 1% of speed.
It's pretty good.
That's pretty damn
and
good.
that's 3/4 inch off. You know.
It's
I tell you what, you go back and, to drivers 10 years ago, there's a big difference there.
Yeah.
I mean, dead center, maybe not too much difference, but I mean, you hit 3/4 inch off toe and lose 1% of your speed. That's pretty good.
Yeah, and we got plus 0.2 launch change, and at plus 0.2, that means it's going to be launching at 11.1.
Right.
Right, as an average.
Yep.
So, I mean, that's great.
Yeah.
You'd normally see that high toe one twist, torque, and pop the ball a bit higher and knuckle a little bit.
Yep.
But I'm interested to see, and this is what we do see with that spin change, we actually picked up 3%.
Yeah.
And I think this is where the AI face starts working, is that we're not getting that dead low spinner anymore. They're managing to keep some RPMs on it from that toe strike.
Yep. Pretty consistent, actually.
Yep.
I mean, even, we'll talk about the heel in a bit, but, from heel to toe across, the spin doesn't change much.
Right. And then let's talk about tilt change. Tilt change, we gained an extra minus 1.8, so like kind of 7.8 tilt, which is completely normal for a toe strike, right? More gear effect, doming. Yep. But what you do see is because it starts right of target, that extra little bit of help brings it back on line rather than over line or staying right.
Yeah, so essentially it's basically 10 yards right of where the center shot would be. The center shot's 10 yards draw biased. So it's back to the 0 line in our case, yeah.
And that's why we've done it differently with the graphing this year. You can see the 0 line with the blue there with the toe dots.
Right.
It's actually center of the fairway, and versus the center ones are further up and to the left because they're more draw biased.
Right.
And now let's go down to the carry. We lost 3 yards. I'll take
pretty
that.
good. Yeah, 3/4 inch off center. That's pretty good.
Yeah.
I'm not sure I'd even noticed that.
me neither. No, I should be fine with that. I think I'm going to be 20 yards short with a toe shot.
Right.
Okay, Glenn, nudge it across to the heel. So you're going to move it basically 1.5 inches now, all the way back across the face to 3/4 of an inch in the heel.
And keep in mind that the heel is a much more difficult place to make a club perform well.
Yeah.
Right. You typically use a lot more distance. Usually get cut spin.
Loads of spin.
Yep. And it's all bad.
Spin,
right. Yeah. So it's obviously it's closer to the shaft of the club, so it's actually not moving as fast as the toe. Right. So you lose speed just from that fact as well.
Interesting. So. Yeah, good point. And this is where, when we do move those weights around in the back, with 13 grams moving over that might help with these situations. And
if you get more mass right behind where the impact position is, you're going to get more speed, right?
Yep. Completely different start line. Started left of target, which is what we'd expect.
And stay a little left.
Stay a little, and this is interesting. I don't know if we're only just kind of getting into the robot, but when you hit it on the heel on the golf course, sometimes it stays left, sometimes it cuts back because you do get that gear effect, which gets tilt more.
Typically, when you get that cut back, they use a lot of distance.
Right.
Right. So I think that's what they're trying to do is not burn up too much speed in
shape.
In a shape, yeah.
Okay. How's that looking, Glenn, for the averages? 17 millimeters in the heel.
It's all 0, 0.
That was great. 0, 0, 0, literally 0, 0, 0, 0 across the board. And then we had 17 millimeters heel, so pretty decent. Okay, so from the heel, we lose 3%, more than the toe, but we kind of expect that.
Yep.
1 degree lower launch than the average. So now we've gone from basically 11 degrees down to 10,
Right.
which is fine. I mean,
it's not too much, really. I mean, typically you see this heel shot quite a bit lower.
Yeah, but you'll notice that in the air, 1 degree.
Yep.
And then we've got plus 2% speed change. So we didn't actually gain as much speed as we did in the heel as we did in the toe. So I think that's a testament to this 10 times AI face.
Yeah, it's definitely working.
Right, it's knocking spin down, which is great because you don't want that flaring up and
right. And typically when you hit heel shots, you do get a lot more spin, and that doesn't help things.
Yeah. And then we did get a tilt change difference. So it did go plus 0.2, so it's actually moved more like to that 5.8 range. So it's still left bias, but not as left bias as the center, which is what we'd expect. And we lost 15 yards.
Yeah, but that's 3/4 inch in the worst place in the golf to go up the hit. I mean, keep in mind, like I said, the heel's moving slower too, so you lose speed that way as well. So, it's definitely not the best place to hit it.
Yeah. Okay. So we're not really going to pass judgment. I mean, we can talk about what's good or bad as we get deeper and deeper into these.
Yeah, we're going to be doing a ton of these over the next month. We've got all kinds of new products coming from just about every OEM.
Yeah.
And once we get through this first initial stage, with all these numbers, then we'll go back and look at individual, groupings of, how is each driver compared to the other ones and stuff like that. But there's lots of stuff to do here.
Yeah. So hopefully that taught you a little bit about what Callaway's tech is, what it does, is it relative to you, and hang around because there's plenty more models to test, and we've got, like Mark just said, more models from every manufacturer to come. We're going to be pumping videos out all through January into February and probably all year.
Yep.
So stick with us, like, subscribe. Let us know what you think about the test, the video, anything you can. We want to make this the best place, the best information for you to understand golf equipment. Don't forget to go to Coolclubs and get fit, or head to a worldwide golf store, worldwide golf retail location near you to buy your Callaway Elyte today.